Hello everyone, welcome to Sequence and Series Class 2. In our Class 1, we were able to look at Introduction to Sequence and Series, and I was able to show us some examples of a sequence, examples of problems we can call a sequence. Okay, I gave us an instance which we call an arithmetic progression, and also give us an instance which we call a geometric progression. So in our discussion today, I am going to show us how we are going to focus on an arithmetic progression. That's the area I want us to go today. I remain Victor Odigoma Ohia. Quickly, in that class of yes, that last class we did, we looked at a problem like this, and the problem says the second, the third, and the fourth terms of an arithmetic progression are x minus 2, 5, and x plus 2. And in that class, I was able to show us how to, the question says find the value of x, and I was able to show us how to do that. And when we were able to get the value of x, we were able to realize, of course, x in that solving was 5. So we'll be able to realize that this term will be 3. Because they say the second, this is the second, this is the third, and this is the fourth. So this second is 3, this is 5, and this is 7. So that is what we'll be able to realize in that solving. Now, I want to use this now to take us into generalizing the concept of an arithmetic progression, because this is an arithmetic progression. Quickly, if you look at these two terms, you realize that the gap between this and this is 2. That's when you add 2 to 3, you get 5. When you add 2 to 5, you get 7. And one might quickly guess that the next term after the next value, the next occurrence after 7 will be 7 plus 2, and that will be 9. And if you care, you can still add 2 again to 9, and you're going to get 11. So this is a progression. It will continue in that order. If, like I was saying in that last class, that if we want to know what the first term is, do you realize that as soon as I remove 2 here now, I will get 1? Yes, that is the first term, what the first term is going to be. Okay, if you are in that class with me, you understand what I was trying to explain there. Okay, now this is an arithmetic progression. Now, can we come to a way or a point in which we can be able to generalize or derive an idea, a concept that will help us to interpret this in any situation? So follow me. If I call this first term, if I call it T1, and it is 1, and the second T2, and this T2 is the common difference there is 2. So it is possibly going to be 1 plus 2. That will give us 3 for the second term. Do you realize that if this T3 now times 3, that you are going to observe this first value, okay, plus, okay, 2 times 2 times 2 times 2. 2 times 2 give us 4. If you add it here, that will give you 5. Do you get that now? Okay. So if you check out the fourth one, which is T4, that is term number 4. Term number 4. You realize that it can possibly also be 1 plus this 2 times 3. I don't know. Let me rearrange it in a way that it will follow a generalized pattern. Let me put 3 here and put 2 here so that you can see what is going on there. What about the term number 5? T5, that is what will be in number 5. Can I also say it is 1 plus 4 now times 2? 4 times 2. 4 times 2 is 8 plus 1. Is it not 9? It's 9. So if that is the case, am I bringing a kind of generalization? Can you picture something in this matter, in this situation? Okay. You realize that I can go on and on and on in generating expressions that can help me to find the terms that are there. Now, let's come over here. If I say let n be number of terms, a be first term, the first value, okay, and d be common difference between them. Okay, you realize that I can, by what you are seeing, I can say T1 is equals to the first term A. Did you notice it? Did you see there? 1 being 1, T1 being 1. Okay. T2, term number 2, being A plus the common difference. Did you see that the common difference between them is 2? Okay. I am building something now. Will you also accept this if I say that T3 is equals to A plus 2 times this common difference? Can you see 2 times that common difference? Okay. If I say T4 is equals to A plus 3 times that same common difference, did you see the 3 times the common difference? Of course, if you are looking at it, you also be looking at the figures, the sequence over there. Wow. Are we going toward moving towards something now? Can you realize if I also add another one and say T5 is equals to A plus 4 times the common difference? You still realize that if I added, yeah, is there T5 first term plus 4 times 2. 4 times 2 is 8 plus 1. That will give us 9. So I can represent it as A first term plus 4 times the common difference. Let's conclude. We can now draw a conclusion here by saying that in this order, if this thing continues, that for every nth term, you see that when n is 5, that is Tn, for every nth term, Tn, what we are going to have is A, this is dot, 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 that is relating to. What we are going to have is A plus in bracket, plus in bracket. Do you realize that when this is 4, that this is like 4 minus 1? And when this is 5, when n is 5, this is like 5 minus 1. You watch how the thing is going. Permit me to say here in brackets, for every n here, this will be n minus 1, then multiplying the common difference. I don't know if you're able to make it an understanding out of this. Now, this I have given you is the general expression for finding the nth term of an arithmetic progression. You will use this expression to find in that. This I have done now is what we are going to do in the next class. I will show you how to use this mathematical expression to find, assuming this is first term, second term, third term, fourth term, fifth term, sixth term, assuming I want to predict what is going to be in term 20, value that will occurrence or event that is going to happen in position 20 in year in 20 years ahead, as the case may be, either in business or in whatever situation. That's the application. Okay, so you realize that as soon as I have what is at hand and I plug it into this place, I can be able to use it to look into the future and get an estimate. I'm sure that this explanation is well understood. This is the general expression for uh, an arithmetic, for finding the nth term of an arithmetic progression. Thank you so much for being part of the class. I remain Victor Odigoma Ohia. In the next class, I'm going to show you how you use this expression. I don't want the class to be too long, so I'll be taking it brief by brief so that you can be able to follow every detail of what I'm giving you here. Remember, we are heading somewhere where you can be able to solve tangible questions that may be given to you on this. Thank you so much for being part of the class. Please subscribe and share to your friends. Click this notification button so that you can be able to uh, get notified when we upload our classes. Thank you so much. You're welcome.